Lee, how's it going? I thought I'd do this for you quick while I was up here in my other office. Actually, no, I was just hiking and thought I'd talk to you about the Little Rocky Mountains here versus my office. I had time. There's some people up there, so I don't want to shout. I might have to crank the volume up on this a little bit, but if you can just bear with me. And if wind comes by, the microphone's not the best. Okay, one thing I have for you is a map, alright? And I'll get to that in a second. It's a map of the Little Rocky Mountains and the surrounding area. The second thing I have for you is the report that map comes from, okay? And I'll have those links below, alright? The map itself is pretty big for a PDF, alright? And the reason why is because it's very high resolution. So once you get it and you go to the link, you'll have to save it as a PDF, and then when you open it as a PDF, you can zoom in pretty close, okay? Now, the map is it's a geologic map, alright? It's a bedrock map, alright? What is a bedrock map? If you come through and you have a big giant power washer and you wash off all these forests and fields and roads and soil and get rid of everything out there that's loose, all the buildings, all the cities, all the houses, everything, you're going to be left with basically bedrock, okay, that's attached to the crust of the earth. If you go out there and you measure and look at the types of rocks that they are, okay, then you can go and, like, say you spray paint each one a different color. Well, if you then fly over in a helicopter and look straight down, you'll see all these colored patterns on the ground. That's what a geologic map is, okay? It color codes each geology type by color. And then there's a little key. The report is where the actual key is, okay? And it has little symbols, little letters, little colored boxes, and it talks all about, you know, Permian this and Paleozoic that and all this stuff that you probably don't care about. But what it does do, I think it's page 5 or 6. I'll make sure I indicate that below. What it does do is it tells you the basic ages. Now, if you go to the Little Rocky Mountains, and for anybody watching this, I'm talking to my friend Lee, who lives out in Montana, and she wanted to know what the Little Rocky Mountains were as far as, you know, rock types when she goes hiking. So if you're just joining now, that's the deal. We're talking about the Little Rocky Mountains in Montana. If you look at it, it's this very isolated mountain range. It pops up above the Earth's surface, okay? The flat part, okay? It's a lot like this mountain I'm on, which I just hiked up 2.5 miles, okay? I don't want to confuse you, but basically you have this dome. And I don't have my whiteboard or anything, so I'll have to catch up with you later at details. If you have any questions, obviously just ask. I'm trying to give you a quick overview, all right, while I'm here. The dome itself is kind of weird, and it took me a little bit to figure it out because I couldn't see the colors right on my monitor. I can't believe this thing. Is this thing recording? Yeah, it's recording. I don't see the little blinking light. Anyways, because that would really tick me off if I got through this whole thing and it didn't record. Anyways, so you have this isolated kind of mountain range, this hill range that's round, and it just pops up above the land surface, okay? You're not quite in the Rocky Mountains. Those are to the west of that, right? You know this. It's kind of like out there in what I would call big sky country, because it's generally pretty low relief. There's not a lot of changes, but you have this mountain range there. Looks great for hiking, to be honest with you, from the maps. But it's weird. When you look at it, the youngest rocks are in the very center. And then when you step out, there's a ring, and this is looking straight down again. There's a ring around it that's the middle-aged rocks, and then on the outside are, youngest rocks in the middle, right next to the oldest rocks, and then surrounded by the middle-aged rocks, alright? So youngest, oldest, middle-aged, okay? With respect to these 3 different rock types that are there, alright? It was kind of confusing because the colors I had on my map, they weren't matching up quite right. But I think I have it figured out, okay? And there was also something else that I had to actually call the Montana Bureau of Mines and Geology to correct on that map. Apparently it's a pretty recent map that they just published online, but there were like 2 major things on the key that were missing. So they're actually going to correct that, and I'll let you know when that update is, or you can just check back in a couple weeks or whatever, and it should be there. I don't want to get into that. What are the 3 types of rocks? Okay, well, there's 2 types of sedimentary rocks, okay, and there's 1 type of igneous rock. Now, sedimentary rocks are, as you know, the rocks that are deposited and turned into bedrock. They're lithified. The process is that you have weathering and erosion on rocks like this, chemical weathering, physical weathering, erosion downhill, usually by river, by water, sometimes by ice, sometimes by wind. In this case, probably water, maybe a little bit of ice because there is some glaciation in this area. But this is long ago. These things are old. These are like 250 million years. This was way long ago. Okay. So you have these sedimentary rocks, and they get laid down, you know, usually around sea level, you know, near the oceans, that kind of thing. And then more and more stuff builds up on them, and they compact, and the water gets squeezed out. It's full of seawater and groundwater, and all these chemicals are, you know, flowing around. So each individual grain gets kind of cemented together, okay? And that's what gives it its cohesive strength and turns it into a rock, all right? It's a very slow process. It takes forever. Provided those things aren't uplifted again and weathered and eroded, they should, you know, stay there for a while until something happens in terms of plate tectonics or some other force that lifts it back up to where we are today so that we can go see it. And then you have rocks that you can go hike on. Okay? There's 2 types of those. There's a sandstone, and there's looks like a limestone. All right? Sandstones are generally from beach deposits, and limestones are from offshore coral reefs or the slow deposition out a little ways in the ocean of microscopic organisms that use calcium carbonate to just use it for their shell, and then they die. They have a really short life cycle, and they die, and there's this constant shower of these microscopic shells falling on the ocean floor. Well, after millions of years of that, stuff packs up. It's like snow, all right? When after a big snowstorm, at the bottom of the snow, it's packed down versus the very top where it's light and fluffy. So it's starting to become lithified down deeper. All right? Now I forget which one's on top. I think the Colorado group, which is named in the key, Colorado Formation, Colorado group, something like that. That one is the sandstone, I believe. And then up above that is the limestone, and I can't remember what kind it is, but it says that there's a mixture of dolomite in there, okay? I don't want to get into the fancy chemical names and all that. It's just a variant of it, essentially. To keep this easy and keep it lumped together, really kind of geology 101, right? But then you don't know what's really above it until you look at other places around there. But you have these 2 sedimentary rocks. Well, then there's the 3rd type of rock at Little Rocky Mountains, which is an igneous rock. Those are rocks that are formed from molten material. Okay? It's melted. It's down there deep, and it's like hot glass when it comes out of the furnace. You know, it's molten. Okay. Now, of the igneous rocks, there's 2 types. If they cool really, really slow at depth, you have really giant crystals in them. I mean, they just have a long time to kind of gel and hang out and form in their little cliques, all these atoms and molecules and minerals floating around. They just have a real long time to just hang out, and the crystals grow big. There's places in like the Adirondack Mountains of upstate New York where there's crystals in rock face like this, and it's pretty much an igneous rock. You're like, oh, man, you know. Plus, you also see the same thing when you have like a chemical deposition of something like quartz crystals inside of a cave. The big giant crystals take the longest to grow. The little tiny ones are really fast, okay? The other one is called an extrusive igneous rock, and those are volcanoes, or other types of hydrothermal deposits that come up really fast near to ground surface where we have atmospheric pressure, and they cool really fast, okay? Examples are like the basalts in Hawaii, the Cascade Ranges, okay, or the Cascade Range volcanoes. You know, if you remember Mount St. Helens in 1980, if you're looking at the mountain with that old film, you know, there was an earthquake first, okay, and it started to slide out. But then there was the big explosion. Well, you know what that explosion was? That was the magma coming up just enough that all the gas and water and everything and all that stuff hit this lower pressure, and it just went. It's like shaking a soda can, opening the top. It just, all the bubbles form and it blows up. Well, that's what blew up. So you first had the thing slide, and then you had this mass move just enough up the throat of the volcano, and it just blew out. And not only did it push and break and fracture this stuff, but it blew out and fractured like the top half of it and just pulverized everything and just covered everything. And that was what the big blast was. It came out and just leveled everything for like 20 miles, killed all them, you know, those trees, and just stripped them down and buried everything down in the total river and all that. I mean, it would look like the moon when it was done and over with. It was bad, and you know, that's what filled all those rivers coming down. Well, when you go back and you look at that rock, it's really fine grain, okay? It's really, really fine grain because it cooled like that. The crystals never had a really big, long time to get bigger, all right?